What's a molar ratio?
A molar ratio is the coefficients used to balance an equation.
What's the molar ratio of Na to 2Na2O?
It'd be 4 to 2.
That's right. Why is Na first?
Because you asked for it first.
Yes. Would you use ice charts and when would you use molar ratios?
Well, I mean, it all just depends on what the person's asking for. If they only ask for one thing, you probably just want to use the molar ratio. But if they're asking for more than one thing, it'd probably be easier to use the ice chart.
What unit should you be in to find molar ratios?
It's easy. It's right here on the board. It says moles.
What unit should you be in to use ice charts?
Right here on the board. It says moles.
If you have 2 grams of O2, how many grams of potassium do you have?
Okay, so it's a 4-to-1 ratio. So you would go ahead and put 4 over 1, and then if it's, you said oxygen was
2 grams.
So you put 2 here, and you have an unknown here.
Why is 2 on the bottom?
Because oxygen is on the bottom. So keep it in mind. So then you cross multiply, and it leaves you with 8 equals x.
And what's 8?
8 is potassium, the number of grams of potassium.
I have 0.177 moles of potassium and 0.134 moles of O2, and your actual yield is 7.36 grams. Find the limiting reactant, excess reactant, how much product you have left over, the percent yield, and the theoretical yield.
Okay, so you said the ice chart. You're good, Dan. And then 7, 4.
You're doing it right. Your X's just look really weird.
0. Divide 4. So then.
Yeah, okay.
Divide 4. That gives us 0.044. That's our number for that, so then we can combine
Yeah.
here.
Yeah.
To 2.1, so is that 0.44. So, did the math here and it came out to be 0.0443 because significant figures, and you combine this here and then subtract it, and it's just going to equal out to be 0. So then you do the same here. Put 0.443, and you do your math, and then you do this minus, do that number minus 0.0443, and it gives us 0.097. That's ours, and then you do, and that's your excess. That's the number, that's the excess reactant. That's what's left over. So then you do it there as well. So then you'll do 2 times 0.0443, and you do, and then that's going to be left over. So it's going to be 0.0886 moles left over.
What are the chances?
Yeah, that's it. Moles produced.
Okay, find the percent yield.
We have 1.68 grams of Fe equals 2.
Yeah, it's like that.
So this camera stopped recording, but this is where we're at. What are you doing?
Converting this into grams.
What's the 94.2 represent?
The mass of this right here. So go ahead and do the math, and that turns out to be 8.35. So with that number, to get your percent yield, number is 8.35. So to get that number, put it like this. Put the actual mass over that. 0.35 times 100, and that will equal 26. Equals that this times 100. And it turns out to be 88.21%.
Yeah. What's the importance of percent yield in an industrial setting?
The higher the percent yield, the more money you make because like you made more.
Find the percent yield. Find the percent yield.
Okay, so I'm gonna put it like this.
So we're gonna have to take a smaller number because one of these reactants in our equation.
What number's on top? What number's on bottom?
The actual versus the theoretical.
Yep.
That.
So then you do 4,4535 equals that times 100. You want to make sure that they're in the same units, by the way.
It's like the action.
And then so you get 80. You get 88.2% as your percent yield.
Okay, and what does that percent yield represent?
The max you can get, so like 88% of like the max you can make.
So in this case, it's 88.2% of what?
Yeah.
This right here, this number.
Yes.